Hello students, here we are going to find out what is a position vector, then a displacement vector and a separation vector. You know what is a position vector? Position vector defines the position of a particle at a point. Okay, if we have the position right here, let it be at the point P, which is denoted by the components x, y and z. So you have, this is the origin O. From this we draw a vector r. This is the vector r. This is the position vector r. So what is vector r? Vector r is the position vector, which is nothing but x plus y plus z along z direction. These are the three components of vector r. This vector is called the position vector. Okay, so you know about position vector. Now what is the magnitude of this vector? The magnitude of the position vector r is represented by this symbol vector r in the two parallel lines. Magnitude of r, or what is magnitude represents? Magnitude means the length of this vector. Okay, or it is nothing but, if it is the position vector, it is the distance. Okay, so magnitude of r is equal to square root of x square plus y square plus z square. This gives the magnitude. Since it is a vector, it should have a direction also. So what is the direction of this position vector? The position vector, the direction of a vector, is given by the vector divided by its magnitude. So what will happen when we divide it by its magnitude? Its magnitude will cancel. What will be remaining? Only the direction. So that direction vector is denoted by the vector with a cap. So this is called the direction or the unit vector along r. This is also called the unit vector along the vector r. So this gives the direction of vector r. So this is given by vector r divided by the magnitude of that vector. So what is vector r? It is xx plus yy plus zz divided by its magnitude. It is right here. It is equal to root of x square plus y square plus z square. So when we divide this vector r divided by its magnitude, you get the unit vector or the direction of, you get here the direction of vector r. So you have found out what is the magnitude as well as the direction of unit vector r. Now we are going into the second category, which is the displacement vector. So if this position vector p having the position x, y, z, and we define as a nearby position as x plus dx. This vector has been changed from x to x plus dx, then y to y plus dy, then z to z plus dz. Okay, so this vector from this point to this point, that vector is called the displacement vector, or it is called the infinitesimal displacement vector. So what is the infinitesimal displacement vector? It is the distance from this point xyz to x plus dx plus y plus dy z plus dz. So it is given by this relation dl. What is this dl vector? Dl vector is nothing but the infinitesimal displacement vector, that is equal to dx x along this direction, dy along this direction y plus dz. This is called the infinitesimal displacement vector. Okay, so we have found out what is position vector as well as displacement vector or the infinitesimal displacement vector. Now, what is a separation vectors? Separation vector. Usually in electrodynamics, we will be dealing about one source point. So, from where the field is starting, it is called the source point, and another point is that field point. So, we will be dealing about these 2 points usually in the electrodynamics. So, we have specific notations for the field point position vector as well as source point position vector. The field point position vector is represented as vector r, and the source point vector is represented as vector r dash. Okay, this is from the origin of the coordinate system. Okay, so this is our coordinate system. This is the coordinate system, origin of our coordinate system. Here, from here, we have defined the source point as well as field point. So this vector, this is like this. This vector r is throughout taken in this book as the separation vector. So what is a separation vector? It is nothing but the vector between source point to field point. You note the direction. It is from source point to field point. That is the direction of this separation vector. So how can we find out the vector r? So we can find out vector r by this relation. So you know the triangle law. So from that, what is vector r or the separation vector r is equal to vector r minus r dash. How will you get this? So this is the triangle law of addition. So this side, what is this vector r dash plus this vector r, separation vector r is nothing but it is the position vector r of the field point. So what is vector r or this separation vector r is equal to vector r minus r dash. This is how you get this relation for the separation vector. So the separation vector r is equal to the field position vector minus the source position vector. Now what is the magnitude of this vector? R is equal to magnitude of r minus r. Okay, now this is the magnitude. Okay, you can find out what is the magnitude of the separation vector and what is the direction of vector r. You can find it like this, the vector divided by its magnitude. So the unit vector r, sorry, not this r, this one r. This unit vector along this direction is given by the vector separation vector r divided by its magnitude. Okay, so you can what is this vector? It is nothing but r minus r dash, and that the magnitude divides this by its magnitude. So you get the direction from r dash to r. So you try to find out what is the direction. It is from here to here. So this is our direction from r dash is from source point to field point. What is the direction of the field towards this point or at the field point? Okay. Now what is this r? What is this vector r? The position vector of the field point, that is nothing but xx plus yy plus zz. Okay, now what is this r dash? R dash is, the vector r dash is equal to x dash, x plus y dash, y plus z dash, z. So what is r minus r dash? It is x minus x dash into unit vector x plus y minus y dash into unit vector y plus z minus z dash into unit vector z. Okay, this is our vector, the separation vector. This is called the separation vector. Okay, separation vector. And what is its magnitude? It is nothing but it is the square root of the components. It is x minus x dash square plus y minus y dash square plus z minus z dash whole square. Now this is its magnitude. Magnitude of separation vector. Now what is the direction? Direction of this vector, it is the cap unit vector along R. It is nothing but the vector divided by its magnitude. This vector. Okay. So this is the direction of vector R, or the separation vector. So separation vector is nothing but the separation between field point and source point. So it is direction, the direction of that vector will be from source point to field point. Okay.